Welcome to EDU World Space.
24.90. We have some positive charge sitting at a point P, and we have a negative charge of mass M moving in a circle at a constant speed at a radius r1 centered at P. And if we want to increase r1 to some larger r2, what is the work we need to do that? So our little particle has potential and kinetic energy, and both of those are going to, the conservation of energy is the kinetic plus potential plus the work equals the kinetic plus the potential after the work is done. So we need to find an expression for what the total energy is in terms of just whatever radius, or for any radius. So we have, just going back to some of our, mechanics of like uniform circular motion, the centripetal force that Q is applying is going to be QQ, that big Q is applying, over 4 pi epsilon naught r squared. This is m times a centripetal. The centripetal acceleration is also v squared over r. So just multiply this by m, set it equal to this. We find that mv squared is equal to k Coulomb's constant times the product of the charges divided by the radius at which it's moving. So the kinetic energy is just 1/2 of this. So k QQ over 2r. So far, so good. Potential is easier. It's going to be negative QQ times Coulomb's constant over r. So the total energy, which must remain constant, is the sum of these two things. And so this is negative k QQ over 2r, because we have half a thing minus a whole thing is going to be negative half a thing. So now, at R1, the energy is just going to be negative k q over 2r1. At 2, it's going to be negative k QQ over 2r2. And so the work is what's needed to make up the difference in those two energies. Because if there's not work from some external source, then the conservation of energy says that nothing is changing. So this is the final minus the initial. And so this is QQ over 8 pi epsilon naught times the difference of the reciprocals of our two radii, 1 over r1 minus 1 over r2. The reason that this is 2 this is 2 minus 1, and this is 1 minus 2, is that these both have negative signs. So we just put that inside of our, and it swaps them around. So this is our expression for the work needed to do that.